Hi students, all of you welcome. Welcome to Suneel Engineering Academy. I am Suneel Kumar Bandaru. Students, in this Transformers through topic wise MCQ series, we have already completed I think 9 sessions. It is the 10th one. If you want previous, just click on the playlist. You can find out the previous. Let us start the session. We have completed all these questions. Students, I have given Telegram link in the description channel. Please click on description box and you can find out the Telegram channel link. Okay. So now I think three-phase transformers we have to discuss. Testing also completed. Yes, three-phase transformers. Coming to the first question. In three-phase transformer, the load current is 139.1 amp and secondary voltage is 415 volt. The rating of the transformer would be dash. The rating is nothing but in kVA. So in case of three-phase, the kVA is nothing but root 3 VL line voltage, line current. Okay, so until unless they have given, we have to consider it is a star connected. Star connected, whatever the values they have given, that is line voltage only. Okay, here the current is nothing but line current and phase current, both are same in the star connection. So 139. So if we calculate, we will get approximately 99.9 something, that is 100 kV. Okay, that is 100 kV. Okay, so the answer is options. Answer is options. Coming to the next question. A three-phase transformer has its primary connected to delta. So consider as primary, consider as secondary. Primary is connected to delta, secondary is connected to star. And secondary to primary turns ratio, secondary to primary turns ratio is 6 given. And primary voltage given 200. Then what about the secondary voltage? So while calculating three-phase transformers, we have to remember one important thing. We already know in the network analysis. Here, in case of delta connection, we know voltages are same. Line voltage is equal to phase voltage. But line current is higher, correct? Line current is equal to root 3 into phase current. In case of star connection, line voltage is higher na root 3 times of the phase voltage, and line current is also equal to phase current. From this one, phase current is less, that is 1 by root 3 times of the line voltage. Very important. And turns ratio is always with respect to phase only, not line. Okay, so number of turns per phase. We always take idea of the turns, number of turns per phase. Here also they have given ratio per phases only, not per line values. Okay. So in this case, they have given primary voltage and asking the secondary voltage. Okay. So delta is the primary now. So whatever the voltage they have given, that is the line voltage, correct? This is the line voltage. And in the delta, line voltage and phase voltage both are same. Okay. And this is the, let us take this is the primary line voltage, and we need to find out this secondary voltage within line values. So we have the turns ratio. We know V2 by V1 is equal to N2 by N1 in with respect to phases. Okay, so from this one we can find out V2 phase now, V1 phase or V1 line, both are same in the delta. VL is also equal to V phase, both are same. Okay, so 200, N2 by N1 is they have given 6, so 1200 is the phase voltage in case of secondary. So whenever we have the phase voltage, but they are asking just a secondary voltage means we need to find out the line value. So line value is equal to root 3 times of the phase value, 1.732 into 1200. Okay, so almost 2078 volt. So the answer is option A. So the answer is option A. Okay. So here I have given lot of writings and all this, but in the examination no need. Simple idea. Listen carefully. Three-phase transformers. So whenever they have given question on three-phase transformers, we have to be aware about delta and star connection and their corresponding line and phase relationship. Okay. Primary they have given delta, secondary they have given star. Primary delta, in delta line voltage and phase voltage both are same, that is 200. In the secondary we have to find out the line voltage. We have the relation between these two. V2 phase by V1 phase is equal to N2 by N1. So from this one we are getting V2 phase. Whenever we are getting the 1200, somebody will give the answer as option 1200, but which is wrong. Why? Because we have to give the line value. Line value is equal to root 3 into phase value. So 2078. Coming to the next question. K is the phase to phase voltage ratio. Then line to line voltage ratio in a three phase star delta transformer is dash. All of you listen carefully. For this type of question, just to follow my methods. I will use step by step. The first step is nothing but what is the transformer they have given, we have to take that one. So which transformer they have given? Star delta. So star delta, mark like this. Okay, then phase to phase voltage ratio. Phase to phase voltage ratio they have given K. K means K is to 1. Okay, K is to 1. They are asking line to line. In case of star connection, line value is equal to root 3 into phase value. So VL is equal to root 3 into K. Okay, root 3 into phase value, that is root 3 into K. Delta connection, line value is equal to phase value only. So that is line value is equal to 1. Now what is the line to line voltage ratio? Root 3K by 1, that is nothing but root 3K. Root 3K by 1, that is root 3K. All of you clear? Once again guys, whatever the transformer they have given, note it as first point, step 1. Step 2, note down the phase to phase. Step 3, convert into line values. Okay, if they are asking delta to star, reverse it, then you will get the answer. Okay, so let us take that type of question also. Here listen carefully. From this question you can get a clear understanding. A delta star transformer. So what is the first step? Delta star transformer. Note like this. As phase to phase. Second step. What is the second step? I said phase to phase voltage. In case of delta, they have given A. In case of star, they have given 1. Okay. Don't feel that this A or K or turns ratio or transformation ratio. Okay. So just they have given ratio, we have to take like this. Now they are asking line to line voltage ratio of star delta. First of all, find out line to line ratio here. Line delta line voltage is equal to phase voltage, same. Star line voltage is equal to root 3 times. So now you are getting line to line value ratio for delta star, but they are asking star delta. Na? If you want star delta, reverse it. Root 3 is to A, that is equal to root 3 by A. Clear? So root 3 is to A, that is equal to root 3 by A. So the answer is option D. So like that you have to do. First step, whatever the transformer they have given. Second step, write down phase to phase ratio, what is they have given, and convert it into a line value. If they are asking same connection, give the A by root 3. They have given reverse root 3 by A. Okay. Coming to the next question, guys. Which transformer the tertiary winding is used? In which transformer the tertiary winding is used? Tertiary winding generally used in, this is a third winding that is used in star connection. So star to star connection. Okay. Coming to the next one. Which of the following connection of transformer will give highest secondary voltage? Will give highest secondary voltage. For example, let us take the primary and secondary. First of all, if you can consider delta means no conversion. Line voltage are same with respect to phase voltage. So that means here, if you give the 100% primary, then secondary also will get 100% voltage. If you can consider star to star, these are star to star, both are same means if you give 100%, you will get 100% secondary. Okay, now the real thing is delta to star. Here, if the delta is 100, the primary voltage is 100. Whenever coming to the star is nothing but root 3 times of the phase value, root 3 times of the 100. That is nothing but you can say 173.2%. So that means 73% you are getting higher. So that means here you can get high secondary voltage possible. So delta to star, highest secondary voltage, and star delta. So star, if it is a star is 100, coming to the delta. Okay, so whenever coming to the delta here, whatever the value given they have, that is line value. So convert it into a phase. 100 by root 3. So 100 by root 3 you will get. That is 57.7%. Okay, so that means lowest secondary voltage. Okay, so if you are giving line value 100, here also 100, here 100, here also 100. Whenever coming to conversion delta to star, in star line value is equal to highest, root 3 into 100. Here in star it is the line value, VL is line value, then what about the V phase? 100 by root 3. It will be transferred to here as V phase, but the secondary is delta. Delta case V phase is equal to V line now, that is equal to 100 by root 3. That is less value, less voltage. So lowest secondary voltage is star delta. So here they are asking highest delta star, delta primary star secondary. So the answer is option B. Delta primary star secondary. So the answer is option B. Okay. Coming to the next question. Start connection or VV connections. These are used for dash. This is used for conversion of phase to phase conversion. Okay. Conversion of, that is like 3 phase to 2 phase or 2 phase to 3 phase. 3 phase to 2 phase conversion or 2 phase to 3 phase, vice versa. So the answer is option C. 3 phase to 2 phase and 2 phase to 3 phase. Transformer operating in parallel will share the load depends upon. How the load is depends upon? The load is depends upon percentage impedance or Z per unit. Based upon Z per unit, the load is depends. Okay, so the answer is option D, percentage impedance. Buchela's relay is operated by dash. Buchela's relay is nothing but gas actuated relay. It is the gas actuated relay. Okay, so here gas pressure, it is operated by gas pressure. Buchela's relay can be installed on dash. Buchela's relay is operated whenever there is a oil. So it is a used in oil transformer. Okay, so oil transformers is nothing but oil cooled transformers. Buchela's relay gives warning and protection against dash. It is always gives a warning and protection against internal faults. Internal faults only. Coming to the next one. The load carried by VV connection. The load carried by VV connection is 1 by root 3 times of the original load, that is 57.7%. So the answer is option B. 57.7%. In a Scott connection, if the turns ratio of main transformer is K, then teaser transformer has a ratio of dash. Teaser transformer have the ratio of dash. So if teaser transformer have the ratio of always root 3 by 2 times. So root 3 by 2 into this K. So the answer is option B. Okay. Coming to the next one. Which three-phase connection can be used in a transformer to introduce a phase difference of 30 degrees between the input or between its input and output of the voltages? Okay. So here, if you are going to connect the transformers in parallel connection, then there must be having same phase group. Okay, here we have two types of the phase group. Coming to the phase displacement, based upon this phase displacement, we have two phasor groups. Phasor group 1 and phasor group 2. Okay, so in case of phasor group 1, we are getting phase displacement maybe 0 degrees or 180 degrees. 0 or 180 degrees. This the transformers example, whenever both primary and secondary are same, then there is a chance of 0 or 180. In case of coming to zigzag case, delta zigzag star, that is here zigzag case reverse. Phasor group 2 having 30 degrees or plus or minus 180 plus or minus 30 degrees. This group, okay, that is 210 or 150. So in this group, reverse, one is a delta, another one is a star. One is a star, another one is a delta. And here same, star, zigzag, star. Okay, so these are only if you are going to operate in parallel, we have to use the two transformers maybe in the phasor group 1 or phasor group 2. Okay, so here question is phase difference 30 degrees between 30 degrees, there is a possible of delta star or star delta. Okay, star star no, 0 or 180, delta delta no, delta zigzag star no, that is 0 or 180. In case of star delta or delta star only, we have 30 degrees phase displacement. So can give the answer as option C. Okay, coming to the next question. Two single phase transformers A and B with equal turns ratio have reactance of J3 ohm and J9 ohm referred to secondary. When operated in parallel, the load sharing of 100 kilowatt and 0.8 power factor lagging between A and B transformers would respectively dash. How the load sharing? I have already given a load sharing based upon the percentage impedances. Okay, so generally the load sharing is proportional with percentage impedance. Okay, that is inversely proportional 1 by Z. So while operating in parallel, the load sharing here, load is 100 kilowatt. Okay, already kilowatt given, so there is no need of to take power factor. Then A and B transformer would be respectively dash. So it is inversely proportional to impedance. Higher the impedance, lower the sharing. Lower the impedance, higher the sharing. So that means here impedances ratios given as J3, J9. That is 1:3. 1:3 means then KVA ratio, load ratio. Reverse 3:1. In the 100 kilowatt, 3:1 means 75 and 25. So the answer is option B. Okay. Answer is option. Clear? For example, if you have the two resistances or two reactances are connected, how the current is divided? Inversely proportional with that, na? Example, here it's reactance is J3 and one reactance is J9. How the current is divided? Current in J9 is equal to opposite, the total current into opposite by total. So same like this here also. Inversely proportional means the load shared is total load into, okay, total load into opposite. Opposite means J9 by 9 by 9 plus 3. That means 12. Okay, 12 means 3 ones, 3 fours. That is 20. Just wait. 12 means 3 by 4. Okay, 3 threes, 3 fours. So 100 into 3, 4 ones, 4 25, 25 into 3, 75. So one is a 75, another one is 25. No need to calculate. Okay, but no need this one also. Load sharing is inversely proportional with their impedances or reactances. Higher the reactance, lesser the load sharing. Okay. So the answer is option. Coming to the next one. In normal operation of 400 volt 50H transformer, the total iron losses are 2500. The supply voltage and frequency are reduced to 200 volts and 25 Hz respectively. The corresponding loss is 850. The eddy current losses at normal voltage and frequencies are dash. The eddy current losses at normal voltage and frequencies are dash. Okay. So whenever they are asking eddy current or hysteresis, whatever it may be, we have to check V by F ratio is constant or not. V by F ratios. 400 by 50 Hz transformer, whenever it is supplied to 200 volt to 25 Hz. 8. So that is V by F is constant. V by F is constant. Okay. So whenever the V by F is constant and we have the total iron losses is nothing but AF plus BF square. AF plus BF square. So that is initially the total iron losses are 2500. Whenever this changes, then the iron losses will be AF plus BF square, values are 850. Now the eddy current losses will be dash. Okay, so whenever coming to the eddy current losses are very higher compared to the hysteresis losses. Okay, so here if these two addition of these two is 2500 and here it will be reduced to this much, then the eddy current will be under normal voltage and frequency. So the under normal voltage and frequency may be more than 850. Okay, then only you will get for example, if these are totally due to hysteresis losses, then eddy current losses may be approximately 1600. Then 2450, that is approximately 25. So maybe the eddy current losses at normal frequency is nearly 600 order. So directly you can give the answer as option B. If you are not getting this a simple understanding, okay, so you need to calculate by using your conventional method. A frequency, what is the frequency at 2550 Hz? A into 50 plus B into 50 square, that is 2500 is equal to 2500. Okay, and the second case, what is the frequency? 25. So A 25 plus B F square means 625 is equal to 850. So that means you need to multiply with the 2. Then A 50, B 1250 is equal to 1700. So from these two you need to solve, then you will get the answer. Okay, that is 1250B is equal to 800 na. Okay, so then what is the B? B is equal to 800 by 1250. Okay, so eddy current losses at a normal voltage and frequency. At normal voltage and normal frequency, in the sense, in the first case, the normal voltage and normal frequency. So that is nothing but BF square. AF plus BF square, na, this is for eddy current loss. So B is nothing but 800 by 1250. Frequency is 50 square means uh, 50 square 2500 na. So ones, twos. So that is 1600 you will get. That is I said. Okay, that is I said. The eddy current losses are always somewhat of higher. So maybe those are 1600 or directly you can do. Coming to the next question. A 2000 bar 200 transformer, single phase transformer has an exciting current 0.5 and 5 amps and core loss of 600 volt. When HV side is energized by ratio rated voltage and frequency, the magnetizing current is dash. What is the magnetizing current? Magnetizing current is nothing but IMU na. IMU. How you can find out the IMU? I naught is equal to root of IW plus IMU vector sum. Okay, that means you need to find out the I naught. You need to find out the I naught. How you can find out the I naught? They have given core losses of 600 watt na. From that you can find out na core losses, iron losses. That is nothing but V1 IW. That is V1 I cos pi naught or I naught cos pi naught is equal to 600 watt. Okay, from this one I naught cos pi naught is equal to 600 by V1. It is energized in HV side, that is 2000 na. Sorry, here 200 volts is exciting a current of 0.5 when HV side is energized by rated voltage the frequency, then what is the magnetizing current? So it is a 2000, then what is the answer you will get? 20, this 2 zeros, 6 by 20. Okay, so that is if you multiply with the 5, 30 by 100, 30 by 100 means 0.3 amps you will get, I think. So this is nothing but IW. So you are getting IW, and you need to get IMU. So from this one, IMU is equal, or IMU square plus IW square is equal to I naught square. So exciting current they have given 0.5. Okay, so IMU square is equal to I naught square, 0.5 whole square minus IW square, 0.3 whole square. That means you will get the answer as 0.4 amps approximately. So the answer is option B. 0.4 amps approximately. So the answer is option. Okay. And the next one, which of the following statement is not true? First one, winding resistances are high. No, winding resistances has to be low na. So which is wrong? Wrong is the correct answer. Okay. Eddy current negligible. Okay, that is ideal. Constant permeability or high permeability, that is ideal. Hysteresis losses are negligible. So these all these are correct. So this one only wrong. So that is the correct answer. Okay. And the next questions are belongs to auto transformer. Those will be discussed in the next session. Okay. Students, so many students are not click on like button. Okay, so if you really not like my classes, I don't get interest to take more. Okay, so if without useful, what is the use of making classes? All these are paid content, guys. Okay, so if you want get this type of content, you need to pay nearly 10,000 rupees for the total course. But here you are getting a free sessions. Okay, and so many students are feeling that now we don't have any notification, then why need to prepare? So if all the students are feeling same like that, then if all the students are started their preparation at the same time of whenever they have given notification, then all will get the same marks. Then who will get into the job? The students who started preparation before the notification can easily get the more score. Can the student only have the very good confidence, and that person only get into the job. So do you want to get that job? Are you in that? Then you have to start the preparation before the notification. How to complete the total syllabus, and you have to practice when, and then whenever the notification came, then you have to you have to start at the test series, and you have to analyze your performance. Wherever the weak point is there, you have to improve that one. Okay, you have to prepare for any exam like that. Actually, you have to complete the total core syllabus before the notification. After the notification, what are the weak points? You have to check and you have to clear that one. Okay, just to opening. Nowadays, no exams are there, na? So just skipping the video. That is due to that one. I may not lose anything. Okay, students, you only lose. Okay, come on, guys. I'm saying that is for the development of you only. Okay, so if you get into the job, then your total family will be settled. Okay, your total family will be happy. So to make your family has to be happy, I'm decided to give the classes. Okay, so if nobody watching means, then I may skip the videos. Okay, so try to share and try to click on like button if you like my classes. Okay, and also give your expression in the comment format. Okay, thank you so much, guys.